So good afternoon, everyone, and welcome to this lecture of creativity, innovation, and inventive problem solving. So till now in this course, we've been looking at different creativity methods, different methods for ideation. We started with a range of methods, and then we looked at different ways to restructure the problem that we want to solve. We looked at the cause effect chain analysis, we looked at function modeling, trimming, and so on. So from today's session, actually, we will want to start to search for solutions. That is what all of you have been waiting for. I have given you glimpses of different solution finding methods like the contradiction matrix, the lookup table that we saw, and stuff like that. So that is what we will start to work on from today. But before we enter into all that, let me give you one good news. So how many of you have made function diagrams of your projects and products that you're working on? Can you just put a +1 in the chat window? How many of you have done that? No one? No one made any function models? Okay, one team has done that. That's it. This makes me rethink.
I think, sir, people are still joining, so I think we can wait for this question.
Okay. So my question was, how many of us have made function models of our product, of the problem statement that we have worked on? So as of now, Malika and Anuj have put a confirmation that they have done something on the function models. What about others? You can put a +1 in the chat window there. In the meantime, Anuj and Malika, how has your experience been? Is making a function model easy, difficult, cumbersome? How was it? How was it when you changed the model, corrected it? What was your experience?
Sir, as of now, we looked at the engineering system, super system components and all of that. But then we again got stuck on one point that we had to discuss in the office hour regarding ki what all, matlab, already existing technologies जो है, that also we will have to include in our idea या फिर just that credit वाला score should we include in our idea. तो हम उस वाले point पे अटक गए थे again. When we
function model में तो उस सब का कोई टेंशन ही नहीं है ना मलिका. Function model तो
That's true, सब का टेंशन नहीं, but फिर हम और आगे proceed ही नहीं कर पा रहे थे, जैसे हम और discussions हमारी आगे बढ़ रही थी.
Okay, तो आपने बनाना शुरू किया, आपने component analysis तक शायद करा होगा, उसके आगे आपने भी functions नहीं define किया. I get it. Anuj, what was your experience? Yeah, same team.
Yes. No, sir. So we are not in same team. So like we started on brainstorming the question, and after that we shortlisted our question, and after that we researched on like what are the present solution for that problem, and after finding some solution, we again trimmed our problem, and now we are on a very sub problem of our very main problem. So like we are now finding the solution for that sub problem that we have achieved now, like recently.
Okay. तो function model जब आपने trimming करी तो उससे पहले function model बनाया होगा फिर?
Not that pen and paper work. We just like discussed that orally, so we didn't made that.
तो function model आपने भी नहीं बनाया?
No, sir. No, sir.
Okay. Anyone else has worked on a function model yet already or no? Okay. So whether you have made it or not, it doesn't make a difference. I will anyways share a particular tool with you. This tool is called Tech Optimizer, and this tool is not publicly available. It is available only in closed door settings. So you have to maintain the confidentiality of this tool. You cannot just share it forward and distribute it widely. This is the evaluation version that we have, and this evaluation version was released way long back, around 10-15 years back, much earlier than that. This does not require any installation. It is an executable file, so you simply run the file and you will be able to use this tool. And the beauty of this is that, so unfortunately, no one of you confirms that you have worked on a function model. But if you would actually make a pen and paper function model, you will realize that first time write model banana is very difficult, because this is the first time you're doing it. So to get it right the first time can be very tricky, and then you have to erase, you have to cut, you have to make it multiple times, and it becomes very cumbersome just to make the model. This tool, because it's software, so it makes it much easier to build those models, and lots of things, functionality is already included. So component analysis, interaction matrix, everything will just come in. You don't need to work on XLS. You don't need to work on all those things. You just open the tool, start filling your data, and there it is. Okay. So this tool I will make available in the Google Classroom after this class. You can download it, and you can, there's no need to install it. As I said, you can start to use it. Our project presentation, I initially thought that I would want to keep it on in the next week's classes. So something like next Tuesday, we will just extend the class, this particular class from 4 to 5:30 ki jagah, we could do it from 4 to something like 7, and we could do it. But then I could sense that a few of you are not ready. So we will have our project presentation on the day of the mid-semester exam. The mid-semester exam is on 8th. So on 8th, 3 to 4 is the mid-semester exam. In the morning, something like 10 to 1, we will have the mid-semester presentations for the project. Okay, in which you will have to show what all you have done in terms of where you started from, CA, what happened out of all the things that you did, and what is your problem statement now. We will talk about solution finding techniques today and next Monday and Tuesday. So how have you utilized those schemes, and what kind of solutions are you now looking at? So whatever it is, whatever the status is, you have to present that. And I expect function models, whether it is a product model or a process flow model, the tool will enable you to make all of these models. Okay. So I would expect that to be there, and I would expect you to use the tool to quickly make one. You know, it actually speeds up the function modeling part much better. Okay.
So what can we expect in our exam, like this mid-semester exam?
Yeah, questions?
Like questions like a pattern, like MCQs, or just subjective question?
No, it will be a mix. There will be written part. You will have to write. Because you can't. So you will have to make function models, and you have to show them.
Okay.
Okay. So while I am giving you this tool is to help you in the project. I don't think you can use this tool during the exam. In the exam, you have. We will see. It will be simple function models that I will ask you to create.
Okay.
Anything else? So you know that our exam is scheduled on 8th, and the written exam time is from 3 to 4, and the project presentations will be on 8th morning from 10 to 1 or 10:30 to 1:30. What do you prefer? 10:30 to 1:30? 10 to 1?
Yes, sir.
Okay, I will propose the schedule on Classroom, and then that will be fine. Okay. So great, guys. Then let's enter into the solution finding zone today. And just give me a minute. So here you are. So as I said, till now we have done quite a few creativity methods. We have done HIT, MSC, we have done trigger, 635, superheroes, role storming. 9 screens we have done. Scamper, we've not really talked about much, but when we talk about inventive principles, we will talk about Scamper then. Force fit also we have done. So it's a good range of ideation methods that we are introduced to now. And we will use these ideation methods to arrive at solutions. But before we enter into that zone, let me tell you a small story. So do you have you seen ants working and finding something that they love to eat? You've seen long chains of ants just walking down, just crawling along the side of a wall or slanting up through the wall and all that. You've seen ants?
Yes, sir.
Yes, sir. Yes, sir.
So do you think they always know where the food is, and they always form these queues, these chains, and these lines meticulously straight lines, always so easily? How does it happen?
So lines, I think they always form, but not every time they get food. Like they search food, and if they get, then.
So when they search food, how do they search food? Do you know that?
So well, I think like with smelling bar, sense of smell. So I think.
So let us say this is the ant hill, and let us say there is a pot of honey here. They are able to smell that there is honey. There is a solution somewhere. How to reach there? So that is the state that you guys are in today, is it not? There is a solution that you have in mind, but it is still in the mind. How to reach there? At times, only the problem is in mind, and there has to be a solution. This problem is easy enough. I should be able to crack it. I should be able to solve it. Even if the problem is not easy enough, it could be a 5-year PhD problem that you are starting to work on. But there has to be a solution. So you have sensed it, you have smelled a solution. How will you reach it now? Let's look at how the ants reach it. So, one thing is very clear, that they do not reach the solution straight away. That doesn't happen. More interestingly, what you should also be aware is that even when there are obstacles, let us say there is a water body somewhere, they still find a way. Let us say this is a water body, a thin streak of water. They still find a way where they say that, oh, okay, there is a bridge, there is a break in this water body. This is where we would cross. Have you seen this? That they somehow find the way. Do they get to find the way right away? No. So what they do is they scout for solutions. The first set of ants leave the molehill and they say, okay, I'm smelling honey somewhere, but let's find it. They smell the honey, they start to move out, they start to search for it, they don't get it, so they come back. Now the next set of ants come, they're not even, so for the first few feet, they don't even search for honey because they can smell, so they have these pheromones. They can smell that my sister ant was already here. Had the honey been there, we would have already cracked it. So they reach this point and now they diversify from here. Again, nothing found, come back. Okay. Then the other ant goes out and checks in the vicinity. Again, no success. The next ant comes and starts to search. Next ant comes, starts to search, and so on. Are you able to see this? So some ant crosses this, then search, and finally honey. So the ant that reaches the honey now follows, traces its on route exactly because of the pheromones. It just traces its on route back and gives the news that, oh, I found honey. Eureka moment. Oh, we found honey, let's all go. And then ants start to move. They first start to follow this route only. Okay. But soon what happens, since there are more ants now, the ants over here see, oh, my sisters are there. So they say, okay, let us go this way. So they start to cut out on the edges. And soon you will notice they are at the shortest path to honey. This is how the creativity process works for us also as human beings. Okay. So first of all, what have we done till now? We've identified a challenge or problem. Have we done that? All of us? We've also collected information. We've tried to see, I think all of you have till now at least started to analyze why your system is still not working, what are the challenges there are. You have identified what is the kind of market size. We talked about all these things. You know, some of you may have already filled the business model canvas. So you've collected information, you have envisaged some stuff. So you've put in some data. Then, now that we have all this information, we now start to connect the dots. We start to incubate and meld the knowledge that we have, and we start to search for solutions. We have to go into divergence sessions, come back again, add more. As you have more experience out of those divergence sessions, you say, oh, these are not working. But this is the most promising direction. Let's get going on this one more. So you just pursue your instincts, you follow your instincts and pursue the directions which you find interesting. And generate ideas, identify the promising ones, and then you start to verify. So this generation of ideas and identifying promising ones is what we are talking about, the solution finding stage. Okay. So these first three steps are a part of problem identification. The next is problem solving. And the last three are concept substantiation. You remember this thing that we talked about? The first stage is problem identification, then problem solving, then concept substantiation. So we have kind of introduced sufficient number of tools to you where you can now identify problems, twist them, turn them to identify which one is the cheapest problem to solve. Okay. And now we are entering into the stage where we say we will solve those problems now. Okay. Towards the end of this course, we'll look at the concept substantiation methods also. So one thing that I would want to introduce to you at the same, another concept that I would want to introduce to you is called 6 thinking hats. This concept was given by this guy, Edward de Bono. How many of you have heard about him? Edward de Bono. No one. Okay, so Edward de Bono is a person who has researched and written tremendously about creativity and creativity methods. And he said that, see, what happens? Why do we not pursue ideas, some ideas, which finally can become a hit? What happened with Nokia, for example? They had come up with the idea of a full screen, touch screen phone. They never pursued it. Apple came up with it and it was a huge success. Today, all the phones that we have are touchscreen phones. So what happens many times is that we kill the idea before giving it due thought, giving it due weight. So to avoid doing that, Edward de Bono proposed this framework of 6 thinking hats. He said that, first of all, whenever you need to solve a problem, you should wear a white hat. What does the white hat do? It is a factual analysis. So all that we've been doing till now in terms of function model, in terms of CA, in terms of problem identification stages, all of that is white hat. The business model canvas, everything is white hat. Okay, we are gathering information, we are doing all those things. Then you wear the green hat. What does the green hat do? It is the hat in which we simply create ideas. The For example, the ideation techniques that we worked on, whether it was superheroes, role storming, 635, trigger, anything, all these ideation techniques, we were wearing green hats. Do you remember I always told you, do not screen anything as of now. Just come up with ideas, list down everything. The role of the scribe is so important in all these ideation schemes that you should not miss out on even a single idea when you are ideating. So green hat is the hat where we talk about creating ideas. After you have all this, big list of ideas, after that you wear a yellow hat, the sunshine hat. You look at all these ideas with an optimistic view. Wow, if this becomes a reality, what all can be possible? And what all could be made possible? What is the value that this would bring to our customers, to our stakeholders, to our employees, whatever? What all opportunities in terms of markets will it open for us? What all opportunities will it open for us in terms of new implementations, new solutions, so on? So then you wear the yellow hat. After the yellow hat, and only after the yellow hat, he suggests that you wear the black hat, where you now start to write what are the risks involved, what are the drawbacks, what are the problems to watch out for, how to manage these risks. That is the black hat. Many a times you will notice that even while we are wearing the green hat, even when we are in the ideation process, we also wear the black hat at the same time. So with the 6 thinking hats, what happens is you separate out different stages of creativity process. So that, okay, idea, let whatever idea that is coming, let me record that. I'm not here I'm wearing a green hat as of now. This is the creativity time. I have a separate chunk of time where I will criticize them and I will cancel out these ideas. No problems. As of now, let me list everything. So you wear the black hat only after you have worn the yellow hat. Okay. Subsequently, after the black hat, after you've listed the risks and everything about the various ideas, then you wear the red hat. This is the emotion time. This is the time where we think about those customer motivations that we talked about. Remember, we talked about customer motivations of pride, of social status, of being good to the environment, sustainability, and so on. What is the feeling that this idea gives me? Oh, yeah, as soon as I think about this idea, I get goosebumps. I'm so excited about it. Or this looks like a very good idea, but somehow I'm not getting a good feeling. I think anyone can copy it. It's very routine kind of an idea. So just wear the red hat and identify ones which you are excited about. Identify ones which you think there are possibilities. And after that, wear the blue hat. So Anuj is asking, how do we judge this? So how do you judge your feelings? You just become aware of your feelings and you write them down. Okay, this we have 4 people in the team. 3 of us are excited about it. So if you notice in the weekly reviews, I've been asking you about how you feel. Now, the amazing thing is I have only 34 students in the class now, 33 students in the class now. And if I post this lecture, even 1 week after this lecture, only 5 views would be there. But in that answer sheet, there are 68 people who have watched, who have attended, and who have said that, and who are feeling about it. So I believe as a class, you guys are very feeling class. Even without attending the sessions, you feel. So feelings, Anuj, we can do. So feelings are, again, it is just about our feeling. It is not about right or wrong. And then we wear the blue hat, which is about, okay, now that we want to do it, let us see how to go about executing it. What needs to be done? I need to do trimming. I need to do this. I need to do that. Whatever needs to be done, then you just go about and get your hands dirty and execute. That is finally, out of, let us say 50 ideas that you may have got, you finally execute one. So at every stage, you are kind of removing something. After yellow hat, you removed some. Oh, I don't see, not much benefit. So I just picked up top 5 or top 10 after the yellow hat. Black hat ke baad I just picked up top 3. So at when you wear every hat, you can, as a team, decide to give some score and then choose the best ones in that round. Okay. But yes, the important thing is that you wear these hats one by one in a sequence. Do not merge white hat with black hat or green hat. Especially green hat, you should not merge with any other hat. Okay. Otherwise, you will completely go astray. Okay. Any questions here? No questions. Great. So another important thing is it is a direction to think. Okay. When I say emotions, so you think about your feelings. It is not that you say, okay, now I have to think red. No, the colors are symbolic. White is pure, simple facts. No emotions mixed yet. Green is fertile, creativity. Yellow is sunshine, optimistic view. Black is dark. What is the dark side of it? Red is emotions, heart, and blue is now execution. Just make it flow like water. So ensure that you separate these things out when you are into the creativity process or when you are in the innovation process.
Sir, is there just a small question? Is there any priority in this particular that which hat is more important, or which hat we should consider while thinking about the solution?
So when you are thinking about solutions, generating solutions, it is the green hat answer, because you're generating ideas.
Right. But sir, no, so you mentioned about the one which is related to the feelings, the other related to the facts. Now, while we are building the solution, maybe our solution at that particular time is something which most of the people will think that it is not feasible, and it is not according to the facts maybe. But our feeling is that we can make it, we can build upon it, we can
Go
create
ahead,
it.
do it. Follow your passion.
So here we are preferring the feelings wala part from the
No.
facts wala
So
part.
realize that when you're finally deciding to execute something, you've already also won the white hat, the black hat. The last hat that you wear is, so see, you had 50 ideas, let us say. Out of that, after sifting everything at the red hat level, you got only 5 of them.
Mhm.
So already it means that you've taken care of all the other things. You've taken care of the positives, the negatives, everything you've looked at.
Right. So the feelings wala part is at the end. So we
Yes.
need to maintain the order.
Yeah. You have to maintain the sequence.
Got it.
Okay. You cannot say, oh, before entering into the ideation process, I have this one idea and this is what I'm very excited about. Let's do it. No, that doesn't happen. Get the facts in place, then ideate. You had one idea, great. As a team, you may come up with 10 more ideas. Then wear the yellow hat, then wear the black hat, then wear the red hat, and then decide, okay, this is the one we will want to execute.
Got it.
Okay. So there are various tools within TRIZ which are used for problem solving. For example, function-oriented search, inventive principles, standard solutions, TRIZ, smart little people, and the library of scientific effects. We will use quite a few of them. We will start with function-oriented search today. In the next 2 sessions, we will pick up inventive principles. So inventive principles, you remember how many inventive principles did we talk about? So when Altshuler had studied those 20,000 patents, he had identified that there were around 40 inventive principles which were commonly used across those 2 lakh patents, more than 2 lakh patents at that time. So there are 40 inventive principles that we will use, play with, and there are, we will see how to implement them. Different ways. We will look at the first level of abstraction where we do technical contradiction matrix. Then we will look at the second level of abstraction where we will come to physical contradiction. Okay. After that, we will have a very short glimpse of standard solutions. And then we will also get introduced to ARIZ. So ARIZ stands for Algorithm for Inventive Problem Solving. So TRIZ means Theory of Inventive Problem Solving. ARIZ is Algorithm for Inventive Problem Solving. So it's kind of a flow chart. Okay. It will kind of structure our discussion around all of that FOS and inventive principles and everything. It will structure it in a way such that whenever you want to solve problems later or anytime, you follow a kind of a flow chart. Okay. ARIZ ke andar we will also implement smart little people. And then there is this additional tool called Library of Scientific Effects. We will not touch upon this in the class, but the tool that I mentioned in the beginning of the class, that tool has this library inbuilt into it. So you can always use the tool to apply the scientific effects and identify solutions. So that is how we are going to plan on problem solving in this part of the course. So today we will start to look at function-oriented search. So function-oriented search is essentially a problem-solving tool based on identifying existing technologies worldwide using functional criteria. So until you have made a function model of your product, how will you do function-oriented search? So since none of you have confirmed that you have made the function model of your system or the product, we will not have a practice session today. I will just give you the theory and we may close the class after that. Okay. But this function-oriented search has to be done on functions that your system is performing. So whichever functions are, need improvement, are happening insufficiently or are happening excessively, and you want to correct them, that is where you would want to use function-oriented search. Okay. Let's look at how to do FOS. So first thing, the function-oriented search in FOS, what we do is we generalize the function. We generalize the function using a two-pronged approach. First, we say generalize it by action. Then we generalize it by object. For example, hammer moves nail. Hammer moves nail. Now, moves is already a very generic function. We can search about where there is any movement allowed. Okay. Or hammer moves an object. So we simply say hammer moves X. So when you say hammer, when you generalize on action, so hammer acts on nail, and then you say object, you say hammer moves X. Okay? And then you see where else is any movement of any other substance done. Okay. Now you remove the concept of nail. You do not say it is just small head of the nail at which you have to hit. Say, is there any other place where movement is done?
So I have a question. So when you say this, you mean, is there any other place where hammer is moving something or anything is moving anything?
It could be either. You could actually also remove the hammer part there. Or you only say the action is movement. Where else is there any movement that is happening?
Okay.
Or okay, this is the nail. Where are other places that nail is used and how is it moved there? Okay, so look at solutions across other places, not just your industry, any other industry where some movement is happening. So it opens up a huge range of solutions that you could look at. Now you cannot go to every industry and look for solutions everywhere. It will just waste a lot of your time. So the guidance is that you look for the leading industry. What do we mean by leading industry? Where performing the same function adequately and reliably is much more important than your industry, or where the same function should be performed in a much more challenging condition. For example, Mostly you will find that military applications or space applications. How would you do this in space? When it comes to products, that is what it is. That is where it becomes, it talks about leading industry. When you will talk about apps or anything like that, suppose you are playing on costing, then which is the most cost sensitive market, and how is that market breached upon by any other company? So you may be providing an app for, say, finance, but then that there are other apps where customers come and they do something about grocery purchase or something like that. How have those apps taken care of the cost sensitivity of our Indian customers? So how will you take care of it? So you look at the same function performed adequately or more in a equally or more challenging condition. So now, since you're talking about an investment financial app, you understand that your target audience may have some money. You can possibly charge them subscription. Growers cannot charge me subscription. But if you look at growers and try to emulate their model, or if you look at some other company, another app, and try to emulate their model, if they are successful, that kind of gives you a quick fix solution to your problem also. And be aware that function-oriented search is definitely much more robust when you apply it to key problems rather than initial ones. So what tool are we talking about over here? Key problems and initial problems. What tool are we talking about? Where did we talk about key problems and initial problems?
CEC.
Yes, in the cause-effect chain analysis. So you notice function analysis, cause-effect chain analysis, they are feeders into this solution finding method. If you've not done those adequately well, you will struggle with FOS also. But FOS can give you very, very quick, very fast solutions for your problem statement. As an example, you wanted to reduce the weight of the drone while maintaining the strength. Can you think of an industry where strength is very important, but you want to also keep it lightweight?
The military sector.
Okay. Something which is closer?
Aeroplane.
Okay. So we thought of such buildings. You've seen big buildings, huge buildings. They carry a lot of weight. They carry a lot of load on them, but themselves, the pillars and the structure is such that they are light, yet able to carry that weight, have the strength to bear huge loads. And we mix these two ideas, and there are these drones which have such ribs so that you can balance and you can have weight like that. Obviously, you can look at aeroplane also, you can bring in that dynamicity also, all those things you can do. But this is a function-oriented search where you see, okay, around me, is there a solution? And you find one and you implement that. So how it is usually done is, first you identify the key problem that needs to be solved. Articulate the specific function to be performed. List down the parameters. Okay, I want the weight to be this much. I want the strength to be this much. This kind of pressure it should be able to bear. So formulate the required parameters also. So I'm working between pressure and weight and all those things. Now you generalize the function. Identify other technologies that perform a similar function in both related and non-related industry. Select the technology that is most suitable based on your requirements and constraint. And then you identify, do you think moving from this drone to this drone was as simple? Probably they did not even have these extra appendages in the first iteration. They simply thought, okay, let me just reduce the weight over here. And they came up with something. Then they must have realized, oh, now the weight is so less that even the wind would take it away. So they said, okay, let us do something else. They might have done some iterations to arrive at the final model there. So you identify the technology. You may not be able to directly use the technology as is in your system. But you know, this is a stable technology already in a leading system, in a leading industry, it's been performing well. So you're confident about it and you solve the secondary problems required to adapt and implement it in your solution. Huh? Let us look at another example. Any one of you over here is allergic to pollen or has asthma, something like that? So this season is kind of the worst season for those of you who are sensitive to pollen. Anyone here?
Yes, sir.
So what happens? What are the kind of solutions that you look at? At that point of time, drugs or nasal ointments, mask pehen loge, and stuff like that. The disadvantages are they are either expensive or they have side effects or they lead to difficulty in breathing and things like that, or the mask kind of covers your face, so they're so conspicuous you don't want to go out. And so okay, nowadays due to COVID everyone is wearing masks, but think of 2 years earlier or 3 years earlier, you are the only person wearing a mask in a train, so people will all turn around and look at you, what's happening there, is it not? So they're very conspicuous. So we wanted to find a solution. How do we find a solution? So what are the other leading areas where we need to remove dust or remove stuff from air? For example, in an industrial gas purification industry, you want to purify gases. Now, if you do not remove all the particulates from that gas, do you think an industrial gas purification factory would be able to sell anything? No. So their survival depends on removing that dust or removing other particulate material from the gas. So it is their core activity. Without this activity, this industry would not survive. So you look at it, and then you look at technologies where the same function is performed in a evolved or more mature method. So you look at, okay, there are industrial dust collectors. So these chimneys and everything. So there are these industrial methods. And the action principle that they use is what is called as an industrial cyclone. So they kind of create a cyclone by the shape of their chimney or by the shape of their moving, when they're running the gas through the system, they create a kind of a cyclone so that the particulate matters are simply thrown to the wall. The wall may have sticky material, which would simply collect those particles, and you're done with your gas that finally moves out is clean. So it is something like this. The gas enters from one side, it moves into your channel, the dust collector, in the form of a cyclone. And as it moves around the cyclone, the orbit reduces and the speed increases. The particulate matters are not able to move at the same speed as other gases, and soon the particulate matter hits the wall and falls down. Now the air that you send out is clean. How can you apply the same principle for cleaning air in your nose? Now you want to create a cyclone inside your nose. So this is nasal cyclone that you want to create now. So your function-oriented search is to trap pollen from inhale layer. That is the function. You want to trap 95% of all particles which are greater than 5 microns. It should offer low breathing resistance. The cost has to be extremely low, less than $2 per dozen pair. No side effects, and it should be inconspicuous. No one should even notice that I'm using these filters or using something like that. The generalized function was to separate tiny particles from a gas flow. We already looked at the technology of the cyclone, the industrial cyclone there. Now, how to move what is the problem? The problem is how to move the air in a spiral path without using fans. So in an industrial collector, they may have fans to run the air in that path. We don't have that. How do we create a fan in our nose? And then how to trap the dust particles? For them, they simply drop them. But over here, if you drop dust particles, it will come on your lips. You don't want to do that. So how to trap the dust particles also? That is another secondary problem over here. So to create the cyclone, one thing that we already have is, so when we talk about that industry, the air was just there in some place and we have to move it. So you needed fans. Over here, we have our lungs, which kind of pull the air in. So there is a force that is already there. Can we use the same force to pull the air? And so instead of fans, which would push the air, now we have our lungs, which are pulling the air in. So as we pull the air in, the air moves into this particular filter that I want. And the geometry of the filter creates a small cyclone in the nose itself. Okay. And the dust particles are pushed to the edge of this by the centrifugal force, because you're reducing the radius of the movement, and the walls of the device are sticky. So the particles will simply stick here. And you notice we had kept the cost to be extremely low. So now you don't need to clean this nasal filter up. You just throw it away. They are disposable. You wear the next, it's something like masks. You dispose away the mask. Huh? So you just wear the next nasal filter when you go out next. And this, in fact, is a product. This product was, so when I came to know about it in 2011, I actually saw the product in my hand. It was at that point of time available in the US markets. But as recently, I think as 2 years back, IIT Delhi students also created a similar product using exactly the same mechanism. And they had something going, they showed something in their TRIZ event kind of stuff. Okay, they had demonstrated in their open house about, I think, 2 years back, a very similar product. So these are nasal filters which will just plug into your nose and they clean the air. You are taken care of. You don't need to take any medication. There are no side effects. These filters are disposable. They are cheap, and they clean the air. Okay. So any questions about FOS till here?
Sir, I have one general question regarding the product, since it is so much intriguing. So, what's the cost of this product, and why it is not widely available, if it exists?
So probably the students at Triple IIT, for example, they did not have an entrepreneurial bent of mind. They do not have an entrepreneurship minor as we have. They just created it and they left it at that. I don't know.
Okay, so in the US market, is it available widely?
It is available. You can find it. I think it's also available on Amazon or something like that. Yes. Okay. So again, what did we do? We looked at a technology or a principle as it is used in a leading industry, and we adapted the same function to the problem at hand in the same form factor as we needed it. So, the key advantage of FOS is that it adapts existing technologies which are already proven. They are easier to implement because that technology is already proven. They are more reliable, again, because they are proven. And because they exist, you do not need to do a lot of R&D to establish them. So you save a lot of resources and therefore can reach the market in a much cheaper way than inventing new technologies and their applications. Therefore, FOS is the first tool that I'm introducing to you. Before doing anything else, just see, is there someone else solving the same problem? Let us see if we can adapt their solution. If we can, that's the cheapest. Let's move ahead. If we can't, then we look at other methods or other solution finding methods. So the next methods, the next set of solution finding methods, now since you are not ready with your function models, we can't do practice on FOS in this class. We move to the next method of solution finding, which is called inventive principles. Inventive principles, hopefully we should be able to do practice, because the first level of inventive principles does not require any further preparation. You just need to know the problem statement. If you know the problem statement well, if you have analyzed, if you've collected sufficient data about your problem statement, you should be able to apply inventive principles. Okay. If you've not even done that work, then in the breakout rooms, you will struggle. You will not be able to apply these solutions also. So what are these inventive principles about? So remember, we talked about, this is a repeat slide. When in the second lecture, when I had introduced introduction to TRIZ, when I had introduced TRIZ to all of you, the same slide was there even then. So typically, most of our problems are contradictions, where we want to improve one parameter, let us say area, and another desired parameter degrades. So it's kind of a seesaw. You want to improve one, the other one would go down, and you now are just playing around, striking a balance. Oh, I want to improve the area this much, but the speed should not go down. So how many of you have played on a seesaw? Just one person has played on a seesaw? Okay. Thankfully, huh? You guys have played. So how easy or difficult it is to create a strike a balance. Oh, just exactly in the center. Is it easy? A little wind blows and you again struggle. You again have to set back, come back to the center all over again. So in this method of applying inventive principles, what we are looking at is that neither speed nor area, so neither of the two desired parameters, should get compromised when we are finding a solution to the problem. How is this possible? See, in reality, what happens is, as soon as I increase the, reduce the area, the speed degrades. So all my energy is then focused on, oh, how to reduce the area only this much that my speed remains acceptable. That is where we struggle. By using these inventive principles, we could bring in other parameters which we were otherwise ignoring. For example, stability, or for example, accuracy, or for example, what do you say, power. So, or throughput. So there could be something else which we could trade off, which is not really that desired a parameter as of now in the system. So the inventive principles help us to identify those alternate parameters which may not be as desired as the first two parameters are, and we could compromise on those parameters. We could compromise on complexity a bit, and by that we could gain area and also speed simultaneously. So that is what the application of inventive principles does for us. So what Altshuler did was he identified those 40 inventive principles and built a 39 cross 39 matrix of such desired parameters. And in that matrix, in every column, in every cell, he wrote the parameters which were most, or he wrote the inventive principles which were statistically relevant and which were used most commonly to solve the problem there. So, do you remember a few inventive principles that we have talked about? Anyone? We talked about quite a few. Sorry, please.
Trimming.
No. Trimming is a method. Trimming is a tool. Trimming is not an inventive principle. Contradiction. Contradiction means that, okay, I wanted to improve area, but my speed degraded. So it's a contradiction. How do I handle it? Inventive principles.
Sir, one was there like predicting markets to come up with new technology.
That was another tool, theory of, trends of engineering system evolution. Okay, so I get it. You are missing the thing in a big way. You remember these? We talked about segmentation. We talked about equipotentiality when we talked about how ships cross the Panama Canal. Remember? The Panama Canal story we discussed, or we did not discuss.
Yes, sir, we remember.
So these are some examples of inventive principles. Segmentation, for example, and it is so commonly used across various design places. We talked about segmentation in terms of a bicycle, that the chain of a bicycle, the iron chain is segmented into small nuggets so that your chain becomes flexible. For circuit designers, I would say, in SRAMs, bit lines are broken into smaller bit lines so that you gain speed and power. Pipelining for computer architects and others of us, pipelining, we segment a big activity into small chunks and run all of them in parallel so that the overall throughput of the system increases. We can segment algorithms into small parts, which can only be accessed conditionally. So these small parts, they run faster and also help us in doing multi-threading and multitasking and all that. Asymmetry. I think we discussed this also, that are the CPUs that the application processors that you have in your cell phones. They use this big little multi-core architecture. There are 4 big cores and 4 small cores, or 2 big cores and 4 small cores, or 6 small cores. So that you're most energy efficient, but you're also able to get the power to solve big complex problems when you need it. So these are some inventive principles which are very commonly used. Merging, load sharing facility or supercomputers. How are supercomputers made? A lot of small computing elements, they are brought together, they share the workload, and they have a supercomputing power. Universality. One thing takes care of many other functions. For example, fiber to the home enables high-speed internet, can also carry telephone signals, can also carry cable signals and everything. So in Delhi, many of you might already be using FTTH, and that is universality. One thing, but does many functions. Local quality, how to improve something in a local small method. Lunch boxes can have separate compartments for hot food and cold food. Equipotentiality, Panama Canal, we already discussed, or things like homomorphic encryptions, those of you who are working on security, or decoupling capacitors, those of you who are working on circuits. Other inventive principles, common ones, dynamicity, change the way the system is operating. We use it in aeroplanes, we use it in chips where we talk about dynamic voltage and frequency scaling. You can, YouTube, when it senses that your bandwidth is low, it automatically reduces the resolution of the video as it streams it to you. So we see this dynamicity principle also very commonly used. Periodic action, power hammer. So very light in nature, but still gets or hits nails, or drives nails into very hard surfaces also. Intermediaries, bubble packs, packing materials that we use, they're intermediaries so that your product does not get the shock. Self-service, edge computing, intelligent systems, perpetual modes, sensor modes, auto defrost refrigerators. So if you have any questions you do not remember or know about any of these technologies, please do ask. Use of copies. How many have heard about RAIDs, the redundant arrays of independent disks? Many of you are computer engineers. I assume you would know about it. RAIDs. No one? Okay. Someone. Mirror websites. All of us serve the internet. We know mirror websites. To improve customer experience in terms of the website loads very fast, because the closest mirror is where the data comes to you from. Adding another dimensions, Xbox joysticks, 3D transistors, Google Drive. So you don't even have that drive on your disk. You just go to cloud, and that's a different place. Your data is stored elsewhere. So all of this we know about. So these principles, we've been using them. day in and day out, using the benefits of these principles day in and day out, how to implement them to solve the problem at hand. That's the big thing. Are you with me? So, till now, what I've done is I've not even shown you 40 inventive principles. I've just told you that whether you know it or not, you're already reaping the benefits of these inventive principles. The problem statement for us now is how to systematically apply and choose the right inventive principles for the problem that I have at hand. Am I right?
Yes, sir.
So technical contradiction matrix is one way to do it. So for example, let us take this slide from NASA, Glenn Research Center, where they say, okay, if I increase the area of the wings, my lift increases. So I can actually, fly much faster. I can have I can have bigger aeroplanes. I can carry more weight because my lift increases. But can you just increase the area of the wings? No. As soon as you increase the area, what happens? The weight of the wings also increases. So you wanted to, for example, you wanted to carry a payload of you presently carry a payload of 100 tons. You wanted to carry 200 tons. So you said, let me double the area of the wings. Now what happens? As you double the area of the wings, the weight of the wings also increases. So instead of 200 tons, you will still be able to carry only 170 tons, let us say. Not too good, no? So somehow you want to increase the lift without increasing the weight of the wings. Are you able to see this? Is this a kind of contradiction you would also face in your workspace? Have you seen such stuff? Oh, I can have parallel processes running, but then the memory footprint increases. I need much more I need much more RAM. Has it happened with you? Hello? Okay. So now what we do is we formulate the engineering contradiction. We start to write the problem in a format of if, then, but. For example, if we increase the size of the wing, then it generates more lift. But the weight of the wing also increases. Okay. So whatever problem you have, you formulate it as a contradiction. That is the first step to applying the inventive principles. You formulate the problem as if, then, but form. Okay. Once you have it like this, then you actually generalize. What is generating more lift? More force, let us say. And weight is generic enough. So you go to the next sheet and you say, I want to generate more force, where the weight of the moving object should not, or weight of the object should not change. And you see there are these 4 inventive principles mentioned in that column. The principles are anti-weight, sedimentation, thermal expansion, and mechanical vibration. So now you set to think of, now you apply the force fit ideation technique that we discussed in the last class. What was the force fit technique that we discussed in the last class? Can someone remind me? Hello?
So integrating one properties of a particular thing that is totally unrelated to our problem.
So we gave a clue, which I could not directly associate with my problem statement. That was what we did.
Yes, sir.
And then we saw how to find a solution.
Yes.
So now you may think thermal expansion has nothing to do with this wing and force wala problem. Hai na? You go sit together as a team, form 2 teams, do the force fit game and connect each one of these principles to your problem statement. And you will come up with solution ideas. At times, you don't even need to go to force fit. You read the idea, you read the inventive principle, and bingo, you get the solution ideas right there. If not, use the force fit method. Okay. So now you think of how to do it. So let us look at the details of these inventive principles. Anti-weight says, merge an object with other objects providing lift. Make an object interact with the environment such that you get to use aerodynamics or buoyancy or other forces. Segmentation means divide the object into multiple independent parts. Make an object easy to disassemble. Increase the degree of fragmentation or segmentation. Thermal expansion, use thermal expansion or contraction of materials. Use multiple materials with different coefficients of thermal expansion. In one of the office hours, we talked about bimetals. Remember, where we said two metals are kind of pasted together. Each has a different coefficient of thermal expansion. As the temperature increases, let us say the top metal expands more, the lower one lesser. What happens? Your material becomes like a curved thing. So you have more surface area inside. The pressure inside your chamber could reduce. If you were to use this, you could use the same thing, for example, if this was a wall or this was a window, then bimetals would simply open the window for you. We talked about this in terms of building greenhouses. Is someone from that team over here in the class today? Okay, doesn't matter. But thermal expansion, use two materials so that you could get the function done easily. We can't use it for the aeroplane though, but yeah, the inventive principle I was just sharing. And mechanical vibration, there are details of the mechanical vibration idea also. And the principle was solved, the problem was solved by actually moving the air near the wings in a spiral manner. This was a US patent. So they moved the air in a spiral manner. So air would enter over here, enter the wings from here, and it would go out in a spiral manner. And what that does is that for the purpose of air, this then kind of extends the dimensionality of the wing. The size of the wing increases, but the weight doesn't. Because the effective size of the wing has increased, the lift improves, but the weight of the wing does not. Okay, and this is a US patent. Let us look at another example. This is a Turing machine. What does a Turing machine do? It removes stuff from materials. It kind of polishes it, whatever it does. It forms those rings on your material, and when you do that, there are shavings. Even when you sharpen the pencil, you get the shavings. So what happens is that on the belt and on the Turing machine, there are lots of shavings that fall. And when those shavings fall, what happens? The Turing machine gets clogged at times, and then you have to stop the Turing machine and you have to clean that up and then restart the operation. This is not desirable. I want to remove sorry, it's not Turing, it's turning machine. I want to remove the shavings from the turning machine without using complex robots. So the problem is, if one were to use special robots for removing these shavings, then the shavings would be removed and the process would be stable, but the applied equipment would be very complex and expensive. So what do we want to do? We want stability, but we do not want the cost or complexity to degrade. Are you able to see this? So whatever the then and but parts are, you kind of try to generalize them. So you want to improve process stability, but do not want to degrade the complexity of the system. So you come to a little more generic parameters. Process stability, they say use the term as reliability. Complexity, let us, in that particular table, we will look for complexity of the device. You go to the table, row number 27 talks about reliability, 36 talks about complexity. The inventive principles that are written there are 13, 35, and 1. 13 means do the other way around. Where else did we see this inventive principle? We've already seen this inventive principle earlier many times. Do you remember?
Sir, in
Sir,
the
in the
chocolate
very
candy
starting,
example.
yes, sir.
Yes, the examples where we talked about Nina trying to get those chocolates made or polish those
College
nuts
balls.
and bolts and all that. So other way around principle, you remember. What does it say? It says invert the action. Invert the action, make movable parts fixed, fixed parts movable, turn the object upside down. The second one is change physical or chemical properties. Change the object's physical state, move it from gas, from solid to a liquid or to a gas. Change the concentration or consistency, change the degree of flexibility, change the temperature. That is 35. Principle 1 is segmentation. Divide an object into smaller parts, independent parts. Make the project easy to disassemble. Increase the degree of fragmentation or segmentation. So, can we think of a solution by using segmentation? I need to clean this. I need to clean this turning machine and remove the shavings. How can the principle of segmentation help me? Have you cleaned small crevices of your laptop or something like that? Laptop or keyboard, have you tried to clean? What happens? Hello?
Yes, sir.
What is the problem when you try to clean these small spaces?
So the dirts that are present in between the keys and stuffs, they need to be cleaned in some other fashion.
Yeah, it takes a lot of time, it takes a lot of time. Now let us say if I could disassemble the keys like this, I just press a button, all the keys come out. Would it be easier to solve the problem?
Yes, sir.
So that is where segmentation, divided into parts which are easy to disassemble and bring back. If I could do that, I could very simply clean the keyboard. Until that time, it is very difficult. So something like this could be applied to the turning machine also. Can you do that? जहां पे भी shavings अटकती हैं, wherever the shavings get stuck, make those parts disassemblable. Make them easy to disassemble. Then the cleaning part would be fast. But is there a better solution? Is there a better solution? If I say that I could turn the object upside down, what happens? See, when it comes to people, you cannot have people go upside down. But this is a machine. Instead of keeping the machine on the floor, you can hang it from the roof. The shavings would automatically fall down. They will not fall on the machine. Nothing is required. You've used the principle of gravity, a resource which is so commonly available, and you solve the problem. Are you able to see this? Any questions?
Yes.
You want to see one more example? Let us say a styling comb. So a styling comb has some gel in it. So we want to increase the life of the styling comb. So we want to increase the quantity of gel that it has. But then with that, the weight of the comb would increase. So this is not something we desire. come to a typical engineering contradiction where we say quantity of gel is something like quantity of a substance, weight of comb means weight of moving object. And you look at the table and you see that, okay, these are the 4 principles which are commonly used to solve the problem. You could use universality, you could use mechanical vibration, porous materials, or parameter change. We applied all these different principles one by one. Finally, we said, if I could change the state of my object, of my gel, I could do something. So first we looked at porous materials. I had to reduce the weight, so we would drill small holes into the handle so that the weight reduces. To apply the parameter change idea, what we said was, store the gel by dehydrating it. Now, when you are combing wet hair, you would get water from the hair itself. That water, you use capillary action. Use capillary action to get the water into your gel, and then this gel gets released, and you can comb your hair, style your hair with that. Okay, so you're using the water in the hair itself to comb your hair. Now there's a lot of material, gel material, which is there that can be stored without increasing the weight of the comb there. So solidified hair gel is used instead of liquid gel. Okay. Got a fair amount of an idea of how to apply technical contradictions, how to use technical contradiction matrix to identify inventive principles.
Yes, sir.
Yes, sir. Yes, sir.
You want to see one more example of a circuit, let us say?
For sure, sir.
I'm a circuit designer, so I have circuit examples also there. So
Yes.
this is a 6T SRAM cell, 6 transistor SRAM cell. When you want to write into the SRAM cell, what happens is, so there are many constraints. One of the constraints of designing a good SRAM cell is that this particular PMOS has to be very weak. Now, you store a 0 and a 1 inside the memory cell. If the PMOS is weak, the PMOS would transfer a 1. If the PMOS is weak, the current would be less. So the write time degrades. If the PMOS is strong, then you have some other constraint. The writability goes for a toss. So you want the PMOS to be weak and you want the PMOS to be strong. That's a different thing. So what we said was that the side on which I'm storing, I have to store a 0. The PMOS should be weak. But the other side, it should be strong. So how do you do it? We looked at the technical contradiction matrix. We said, okay, we want it to be strong to improve the speed. But as I improve the speed, the strength degrades. The strength comes to a place where I'm no longer able to write a 0. So I do not want that. So the principles that were listed there were counterweight, local quality, copying, and spheroidality. Now, just like in the last example, not all principles you will be able to find solutions with. So I picked up 2 principles, local quality and copying. And by using these principles, we added 2 additional PMOSs here where, okay, I'm not going into the functionality, where you would be able to get additional strength. So to write a 0 into this memory cell, you take this node into to 0 and continue with this node at 1. Okay. Now, this might be Latin for many of you, but those of you who understand circuits, just for them, they will probably understand this. Okay. So what happens when I want to write a 0 here, this PMOS turns on, that improves the strength on this side, whereas this PMOS continues to remain off. So only when you needed it, there was additional strength available, and you also used the principle of copying to arrive at this new memory cell, which was also patented. Okay. So the basic summary is that first thing you do is transform the specific technical contradiction, the if then but statement, the initial if then but statement, into a typical one. When I say typical one, It means that one of the 39 parameters that are listed on this lookup table, you have to use one of those technical parameters. Okay. Then you go to that particular box where your two parameters are listed and use the recommendations that are listed there. Okay. Any questions? Great. So if there are no further questions, I would strongly recommend you to sit together and apply these solutions. So you will have to make the function model of your system to be able to use function-oriented search. And you will have to formulate these technical contradictions in this manner so that you can search from inventive principles if you can get some solutions. Okay. In the next class, we will go to the next level of abstraction. So before we reach the next class, I would strongly recommend you to apply these two methods. Okay. In the next class, we will use physical contradictions as another method to apply engineering contradictions, to apply inventive principles. Okay. So that's it for today. We can, if there are no further questions, we can call it a day. All the best, guys. See you.
Thank you, sir.
Thank you, sir.
Thank you. Bye-bye.
Thank you, sir.